In this video, we're going to talk about Boxplots. It goes along with section 3.3, measures of relative standing in Boxplots in your text, and you can use pages 4 and 5 in your guided notes to follow along with this video. In learning about Boxplots, we should first discuss quartiles. So quartiles are measures of location dividing data into 4 equal parts. Here we have pretend this is a set of data from minimum to maximum. The first quartile would fall where the 25th percentile is. So it would divide the lower 25th percent of the data with the upper 75% of the data. The second quartile is the same as the median, but you can also call it the 50th percentile. The third quartile of the data separates the lower 75% with the upper 25% of the data. So think about quarters. There are 4 quarters in a dollar. Quartiles are the same idea. Now, for quartiles, you can say that from quartile 1 to quartile 3, that's called the middle 50% of your data. If you needed to divide your data up into 50% in another way, you could say from the minimum to quartile 2 is 50% of your data. From the median, or quartile 2, up to the maximum, that's also 50% of your data. Now, when we look at a box plot, the middle of the box plot, where I have highlighted here in yellow, the box part is the middle 50% of your data. And then you'll have whiskers going out to your minimum and your maximum. Some other statistics that we'll need in this section are the interquartile range, the semi-interquartile range, the mid-quartile range, and the 10-90 percentile range, where you find the 90th percentile and you subtract the 10th percentile. The most important one that we'll be using in this section is the interquartile range, the IQR. And that's where we find the difference between quartile 3 and quartile 1. We'll use this to help us find outliers. As I stated before, for a box plot, what we're going to do is we're going to have a box around our first and third quartiles. So surrounding our first quartile, our median, and our third quartile, and then we're going to have whiskers reaching out to our minimum and maximum. These numbers, minimum, quartile 1, median, quartile 3, and maximum, they make up what's called the 5-number summary. Here's an example. It says list the number summary for the given box plot. So here we have a box plot. Remember, we have a box around our middle 50% of the data, and then we have whiskers going out to our minimum and maximum. So 59.1 would be the minimum. 61.5 would be quartile 1. 63.3 would be quartile 2, or more likely we'll call it the median. Quartile 3, which separates the lower 75% of the data with the upper 25%, is 64.95. And our maximum is 67.8. When we're asked to list the 5-number summary, we list these numbers. Our 5-number summary is minimum 59.1, Q1 61.5, X tilde or median is 63.3, Q3 is 64.95, and maximum 67.8. For the next example, we're asked to find a 5-number summary for the given data that make a box plot. We're going to do this by hand, and then I'll show you how to do it in your calculator. So first step is we want to put these numbers in order. The data written in order is 1, 2, 5, 7, 9, 9, 12, 13, 15, 18, and 21. There are 11 items. Now let's find the median, or the middle item of the data. So we have to find the middle piece. There are 11 items, and 11 over 2 is 5.5. So we have to round that to 6. So our locator value is the 6th spot. 1, 2, 3, 4, 5, 6. The median of our data is 6. Median is 6. Our minimum is the lowest data item, 1. Our maximum is the highest data item, 21. So that leaves us to find the first quartile and the third quartile. Well, the first quartile, there are two ways you can think of it. It's the 25th percentile of the data, or you can think of it as the median of the first half of the data. The first half of the data are the numbers I've circled right here. There are 5 data items, so the middle one would be the median. That's 5. So 5 is the first quartile. The other way we can find that is to find our locator value for the 25th percentile. So the locator in that case would be 25 out of 100 times our 11 values. And in that case, what we'll get is 2.75. So round our locator to 3. In the third spot of the data, we have 5. So that's another way to get our first quartile is equal to 5. Now let's find our third quartile, which is the 75th percentile of the data. Once again, you could simply find the median of your second half of the data. So if there's 5 items, once again, the middle item is 15. But I'm going to show you how to do that using the 75th percentile. We'll find our locator value at 75 over 100 times our number of items, 11. In this case, we get 8.25. And we're always going to round up for our locator value when we have a decimal. So we're going to look in the 9th spot. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is, once again, we get 15 for our third quartile. You can choose either method. Using percentiles might be easier when you have larger data sets, but just simply counting and dividing might be easier when you have smaller data sets. Now we can take our 5-number summary and turn it into a box plot. First, make a number line. Now you can mark your minimum, and I usually like to write a label for them. Our first quartile, Q1, our median at 6, our third quartile at 15, and our maximum at 21. You're going to draw a box from quartile 1 to quartile 3 with a line at the median, and then draw lines out to your whiskers. I also like to label the numbers above, and there you have it. You have a box plot. Let's try it in our calculator. To create a box plot in my calculator, I'm going to go to Stat and then to Edit. And you can see I'm going to put my numbers in list 1. I've already put them there. Notice that I did not put them in the ascending order. You don't need to. Next, what you're going to do is press second y equals, which will bring you to stat plots. Go into your first stat plot, and you want to turn it on by highlighting on and press enter. Then when it goes to type, we're going to go over to the second one that looks like a box plot. The first one we see is called a modified box plot. Press enter. And we have our items in list 1. We didn't use frequency, so just leave where it says frequency alone. And what I want you to do is press zoom and then press the number 9 because that'll give us a great window. And what you can see here is our box plot. And if you press trace, you can move the cursor to see the different values. So you can shorthand find your number summary by typing the data into a list and doing a box plot. We can see the median is 9, quartile 1 is 5, the minimum is 1, quartile 3 is 15, and our maximum is 21. Let's look at another example. This example will actually be quicker to do by hand than using your calculator because there are a lot of data items here and it would take a long time to type into our calculator. So let's construct a box plot for the Verizon Airport data speeds. We have 1, 10, 20, 30, 40, 50 data items. They're already in order for us, so we can already determine that the minimum is 0.8 and the maximum is 77.8. We still need to find quartile 1, the median, and quartile 3. Quartile 1 is the 25th percentile, so up here in the left corner we can find our locator. 25 over 100 times 50, which is our n. And we get 12.5. Since it's a decimal, we'll round up to the 13th spot. So we have 10, 11, 12, 13. The first quartile is 7.9. The median is the 50th percentile, P50. So we'll have 50 over 100 times 50. That gives us 25. We have an even number of data, so we need to find the 25th and the 26th spots and average them. So we have 10, 20, 1, 2, 3, 4, 5, and the 26th spot. So we need to say 13.7 plus 14.1 divided by 2. The median is 13.9. The third quartile is the 75th percentile. So we get 75 over 100 times 50 for our locator value, giving us 37.5. So we need to round up and find the 38th value in our table. 10, 20, 30, 1, 2, 3, 4, 5, 6, 7, 8. 21.5 is the third quartile. We have all of our data. Let's make a box plot. Looking at this box plot, we can see that one value is way further out than the rest. It's possible that we have outliers. When we have outliers, we might choose to do something called a modified box plot. Outliers are denoted with a star symbol. The whiskers only extend to the minimum and maximum of the data set values, and then we denote the outliers with an asterisk or just a dot after it. So outliers impact the mean, standard deviation, and scale of histograms, and we have an algebraic way to determine if we have outliers. You have an assignment, and I'll expect the work that I show you for how to determine outliers on your assignment. Let's check to see if our Verizon data has any outliers, and I'll show you the expected work for a problem like this. First, find the IQR, the interquartile range, which is Q3 minus Q1. For our Verizon data, that's 21.5 minus 7.9, which gives us an IQR of 13.6. Now multiply the IQR by 1.5. So we have 1.5 times 13.6 is 20.4. Are there any data less than first quartile minus 1.5 times your IQR? Quartile 1 minus 1.5 times the IQR is negative 12.5. Looking at our data table, there are no negative values. So that means there's no values less than our quartile 1 minus 1.5 IQR. So no outliers on the lower end. Lastly, are there any data values greater than our third quartile plus 1.5 times our IQR? We need to check our table to see if there are any values that are greater than 41.9. 43, 55.6, 71.3, and 77.8 are all greater than 41.9. They are all outliers. Here we've completed the process for finding outliers for a data set. You can use these steps listed 1 through 4 here as general rule for when you need to find outliers. This is the expected work. Now that we have the outliers, we can make a modified box plot. I'm going to make it below the number line. So the middle data will be the same, quartile 1 through quartile 3, and the median. That we have the middle 50% of the data drawn, we can look at the lower end. There were no outliers, so we'll draw our whisker to our minimum, just as we had done before. We'll look at our data set for the highest number that isn't an outlier, and that's 38.5. Let's mark it. On a whisker out to 38.5. Now I'll put dots for all of my outliers. I've listed my outliers with points 55.6, 71.3, and 77.8. Also see a modified box plot on your graphing calculator. I've already typed this Verizon data into list 1, so I'm going to go second stat plot. Turn my first stat plot on, and under type, there's a box plot that has some dots in it. I'm going to highlight it, the fourth item, and press enter. Now I'll press zoom 9, and you can see we have our modified box plot. I can press trace if I want to see what the outliers are. I can easily go back to change this to a regular box plot. Second stat plot, and then I will highlight under type the regular box plot and press enter and then graph it. You can use var1 stat to get the 5-number summary also. Go to stat, calc, var1 stat, and calculate. scroll down to the 5-number summary.